purely revision, oh, not say purely revision, there's only half page thing is new compared to year 11. We learned binomial distribution in year 11, not sure if you still remember that. So first we need to know a definition about Bernoulli sequence. So what is a Bernoulli sequence? It is the same to describe a sequence of repeated trials with the following properties. So basically now you're doing something again and again and again. But like you can't say random experiment do again and again. You will have Bernoulli trials. The following properties must be applied. So the first is the experiment consists a number of n identical trials. So the word identical is important. Identical. So it must be identical trials. So every time your experiment will be exactly the same condition. For example, you toss coins, you throw dice. But any selection without replacement will not be identical trials. Because after you grab one thing from the box, then it's different condition compared to the first time. So that's not identical. But selection with replacement will be fine. Okay, selection with replacement will be fine. Because you select one thing, you record down what is it, and replace back. And then it's the same condition as beginning, and you select another one, and replace back. With replacement is identical trials. Without replacement is not identical trials. That's the first thing. Second is each trial result in one of the two outcomes. So you only have two outcomes. Okay, you only have two outcomes. So these two outcomes, which usually say as success or failure. So S or F. Okay, I have success trials or failure trials. Okay, so toss a coin. Even the result will be head or tails. But I can say to get a head is a successful experiment. To get a tail is a failure experiment. So that's all right. Or for example, you have a box which contains colorful candies. It can have like blue, red, green, like black, all that kind of colors. Even though you will have different outcomes, but it depends on what I'm thinking about. If I'm interested in the number, the number of green candies, I can select from 5 experiments. That can still be a yes or no case. Because when you select a red candy, green candy, you say that's a yes. All the other colors, you will say that's as a no. So it's still a yes and no case, even though you have a lot of outcomes. So it depends on what you're interested in, not really what the exact outcome is. Okay, so what you want? Shh. It depends on what you want. So it can have multiple outcomes, so like different colors, but if I'm just interested in one color, I don't care about what I actually get. I just care about this color. What I want is this color, and this color sign as a yes, and all the rest will sign as a no. That's a yes or no case. And you have a probability for yes, which we said that's a P. Okay, the successful rate for success is a P. Then therefore, the unsuccessful one will be 1 minus P. Okay, the failure rate will be 1 minus P. So successful rate is P and failure will be 1 minus P. I have, for example, I'm shooting the target. I have 0.6 of the chance of shooting the target successfully. That's 0.6. And I will fail for 0.4. Okay, the probability I fail to shoot the target will be 0.4. So you have 2 probabilities only. And the trials are independent. So independent again means I can't have without replacement selections because will be dependent to the previous trials. So each trial will be independent, everything will be like renewed again and again. So it's all different. So that's independent trials. So the outcomes of any trial is not affected by outcomes for any previous trials. So that's the condition for some experiment can become a Bernoulli trials. Okay, can become a Bernoulli trials. So that's a description of a Bernoulli trial. You play something a lot of times. Each time they are independent from each other. They all have successful or failure rate, and the rate are the same for each experiment. So same condition for each experiment. So that's a Bernoulli trials. And then we talk about what is a binomial probability distribution. So how can Bernoulli trial comes to a binomial distribution? Okay, the thing is the number of success in Bernoulli sequence of n trials, okay, is called a binomial random variable. So this is the number of success. So the number of success is called a binomial distribution. Okay, it's called a binomial distribution. So the experiment, like you do this process, the experiment, the trials, the number of trials, you do this experiment, this is called a Bernoulli sequence. You do an experiment multiple times, this is called a Bernoulli. But if I investigate on the number of success I have from this Bernoulli trials, then this is called a binomial distribution. So it's the number of success, that's called the binomial distribution. So for a binomial distribution, the random variable x, okay, the random variable x, which is the number of success in n trials of Bernoulli sequence. So x is the binomial distribution and it is in the Bernoulli sequence. Okay, so have a think about the relationship between those two. One is Bernoulli sequence, is the process we did. And the next one is the result we have for like the interest events. And thus, the x has a binomial distribution with this rule. Okay, this is very important. Highlight that one. This is what you need to write. What you need to tell me at the beginning is like, you know that's a binomial distribution. You know the x is a binomial distribution. For example, everything we did for the previous chapter, they are not binomial distribution. You won't write that. They are just random distributions which can add up to 1. But in this case, if you know something is called a binomial distribution, you will start the line. Okay, so the first thing you will define x. So what is your x? You will define your x. So my x is the number of success of selecting a red candy. So that's the first thing you need to write. Or x is the number of times I can shoot the target. Okay, x is the number of times I can get ahead from toasting 10 times of the coins. So I need to define what is it. So if there's no variable given in the question, so if it's not given, you need to define it. I need to know, like, you can't just randomly start with a capital X and you start to do your question. What is it? What is the x you're talking about? So you need to define it. Just like when you set up algebra equation, you will say, let the son's age to be x, and then the father's age is x plus 20. That's what you need to do first, like define the variable. And the next thing you will do is, you will identify that x is a binomial distribution with how many trials you have done, and what's the successful rate for all of those trials. You need to identify that is actually a binomial distribution. So that's the second thing you're talking about. Okay, first, define the formula, define the variable, which is x or y or n, whatever you like. It's a capital letter. And second is, this capital letter will nominate by binomial distribution with, 10 times of like toasting the coins, and successful rate will be 0.5. So you will say that. Okay, state what is it. And then following on, you do the question by using formulas. So that's the first two steps you need to do at the beginning. And number 3, if it is a binomial distribution, this formula can only work for binomial distribution. It's not going to work for any random distribution. So only works for binomial distribution. So if x is binomial distributed by n and p, therefore, what my probability x equals to x equivalent to. So this lowercase x is the number of success you have. So the x can take value 0, 1, 2, 3. The maximum number is n. Why? It means you have 0 success, 1 success, 2 success, 3 success, until n success, which is all successful. So that's all success. Right, like I can't go n plus 1 because you play the thing 10 times. You can't get 11 times successful. So n is the maximum number you can have for your x, and 0 is the lowest number you can have for the x. And so you can substitute x like for different values, but the formula will be, probability. Let's give you an example. This formula will work like, I will give you an example. So let x become a binomial distribution, and for 5 times, and the probability will be 0.4 for success. Okay, so I shooting the target 5 times. Each time I can shoot the target as a rate of 0.4. Okay, that's this a binomial distribution. So I'm interested in the probability that x equals to 4. I want to investigate exactly 4 times. I can shoot the target exactly 4 times. okay, which is probability 4. Probability x equals to 4. This probability will equivalent to, okay, going back to the formula above, so which is n. What is n? N is 5 in this case. And then I will select 4 from that. So 5 is the number on top, and 4 is how much I want to select it from this 5. I want to select 4 from this 5. And the next component is p to the power of x. What is my p in this case, which is 0.4 in this case? Then to the power of 4. Okay, to the power of 4, because I have 4 success. So it's 0.4 times 0.4 times 0.4 times 0.4. And then the next component is 1 minus p to the power of n minus x. So what is 1 minus p? Is the failure rate. That is 0.6. Okay, failure rate is 0.6. Okay, what's the power? The power is n minus x. N is 5. You already have 4 success. You have 1 failure. So that is to the power of 1. Okay, that's how we can calculate the probability for 4 times success exactly. Okay, 4 times successful exactly for that binomial distribution. For that binomial distribution. Binomial distributed by 5 and 0.4. So how do we calculate this amount? Okay, so you know how to calculate 0.4 to the power of 4, and you know how to calculate 0.6 to the power of 1. It's the combination 5, 4. That's an NCR thing. So nx will equals to n factorial divided by x factorial and divided by n minus x factorial. Okay, that's the number I can have. Okay, I can evaluate that by using this. Okay, n factorial, x factorial, n minus x factorial. The formula is given here. You don't really need to copy that. The formula is given here. So if I want to calculate this one, so what is 5, 4? 5, 4 will be 5 factorial divided by 4 factorial and divided by 5 minus 4 factorial. So what is that? 5 factorial is 5 times 4 times 2 times 3 times 2 times 1. So it's a 5 times 4 factorial. Why I have why I keep 4 factorial? Because I have a 4 factorial at the bottom as well. I can cancel them. And then you have times 1 factorial. 1 factorial is just 1. So this is just equivalent to 5. This is just equivalent to 5. Okay, 5 times 4 factorial, cancel with the 4 factorial below, and you have 1 factorial, which is 1. So just cancel between that, and you have a number 5. Okay, you have a number 5. Okay, so that's just an example what we need to do for binomial distribution. I'll just clear this because I need this space. So this is a formula to calculate. Well, this is like a math function. Do you understand? That's like a math function. It's still back to the previous knowledge. Okay, this is giving your probability by the math function. And you can substitute 0, 1, 2, 3 until n to set up a table again. You can set up a table again. You can find individual probabilities for 0, 1, 2, 3, 4 until n and set up a table if you like. Okay, so I'm interested in a single number and I can evaluate that by using this formula. This formula only gives you exact number of times. So this is only x equals to 0, equals 1, equals to 2. You can't use for x greater than 1. You can't say like 1, 2, 3, 4, 5. You can't go like inequality sign. It must be an equal sign. So x equals to what? Okay, this formula is important. You must remember this formula, and you must remember you can use this formula only if you have this line here. Only if you have write that. Okay, after you write that, then you can use this formula. Without writing that, you can't use the formula below. If anytime you start to use a formula like that, you must have the previous line has x is binomially distributed by what and what. So this probability will affect by 2 things. One is the number of trials. Second is the number of success. Okay, one is the number of trials, how many times you play this experiment. And second is the successful rate. Both factors can affect the final probability. Okay, both factors can affect the final probability. So that's what you need to know for binomial distribution. And let's have a look at example, like a really easy example here. So a survey shows that 60% of the students play in a sport team. If a random sample of 10 students are asked if they are the member of the sport team, find the probability that exact 3 students in the sport team. Let's have a think. What's the 60% and the 10 gives you? Okay, 60% is the successful rate because among, like for example, this class, 60% of the students playing the sport. So if I randomly select one, I'm asking you, do you play sport? You will have 0.6 of the probability to answer me yes, and 0.4 of the probability answer me no. So this probability is equivalent for all of you because it's 0.6 for everyone. So I ask an individual person, do you play sport? There will be 0.6 of the chance you answer a yes. That's the successful rate. So I have a successful rate, 0.6 to receive answer yes. Okay, to receive answer yes. So first of all, I can't see, and also each student is independent. Okay, you are not affected by each other's answer, and they are identical. So it's a binomial distribution. It's a binomial distribution, and I can see there's no random variable x talking about in this question. So I will say first, let x be the number of students playing sport. Okay, that's my number one. I need to set up a random variable. You can't work probability questions without any random variable here. Okay, so you need to use the random variable to talk about what you're actually trying to figure out. So you need to set up a random variable first, which is capital X. And the next thing is X will be binomially distributed because I explained they are all identical trials. Everyone got the same rate of playing or not playing. So I have played that 10 times. I have asked 10 times. So the number of trials will be 10. And successful rate will be 0.6. So X is binomially distributed by 10 and 6. Okay, 10 and 6. That's the notation we should have. Okay, that's the notation we should have. And A says exactly 3 students in a sport team. Exactly 3 students in a sport team. So I want this X to be 3. So 3 among those 10 students. So what I need to find is the probability X equals to 3. That's what I'm trying to find because I want 3 exactly playing sport. So it's the 3 students among those 10 students playing sport. Okay, so it's 10x equals to 3. Therefore, that will equals to, by using this formula, okay, do not really try to remember it, like trying to understand it. 3 from this 10, right? I will select 3 students from this 10 students. Okay, any combination of 3. So I can be those 3, or can be that 3, or can be this 3, like can be different combination of 3 students. It doesn't say this particular 3 students. So it's just a 10, 3. Okay, and then what we have is successful rate. Okay, successful. That's the number of ways I can have 3 students playing sport among 10 students. And I will times the probability, which is 0.6 to the power of 3. Because 3 success, which is 0.6 times 0.6 times 0.6. And also I need 0.4, which is the failure rate. I need 0.4, which is 7 students got this failure rate. So 3 success, 7 failed. So that's the probability. You need to times those 10 probability together. That's the way we're trying to do that. Okay, that's the way we're trying to do that. And I can use calculator to evaluate that. But what I want to tell you is this formula only works for exam 1. or without CAS part, you will only use this formula for exam 1 because this is something, well, if I give you this number, it's impossible to do it by hand. Or if they want you to do, they may only ask you to set up the equation and without solving it, okay, without evaluate it. So it's only working for part 1 because there's no way I can evaluate that by hand. So this will be a CAS question. But you still need to know the formula because it's working for part 1. For example, they can give you a 3 case, n equals to 3. So 3 out of something, which is easy to do. So how I can evaluate this by CAS, which is quite important because part 2 exam, you definitely have this question and you need to use calculator to solve that. So you will go menu. Number 5, probability, and number 5, distribution. Okay, in the distribution, there are a lot of distributions. Okay, there are a lot of distributions. So we will learn the first 3 later. Okay, first 3 later. I think chapter 15, those 3 will be learned later. And we only use those 3, and then we use the one going down here, which is D and E. So we only use number 1 to 3 when we learn normal, and then we learn binomial, we use D or E in binomial. Okay, can you see binomial distribution is those 2? What's the difference between those 2? This one is working for a particular value. So x equals to 1, x equals to 2, equals to something. And CDF is like a continuous value. I'm looking for x greater than 2. So x can be 2, 3, 4, 5, 6, 7, 8, 9, 10. Or can be x less than 5, can be 0, 1, 2, 3, 4. This is for a range of values. And this PDF is only working for a particular value, so x equals to something. So in this case, we have x equals to 3. Therefore, we will have a binomial PDF case. So you just type in whatever you have. You know that's a binomial distribution already. I know I do this 10 times, and I know the successful rate is 0.6, and I know what's the value I'm trying to looking for. I'm looking for a value equals to 3. So that's what all I need to put in my calculator. That's very easy. And I press OK. Where's my OK? 5D. Okay, 10.6. and 3. Okay, that's the value. It's directly give out the value. That value will be the same as you put the whole equation in and trying to figure out. Okay, it's directly replace the formula. The formula is only working for part 1 exam or when it asks you to do it by hand approach. You will use that. Otherwise, use calculator to evaluate binomial distribution. That's 0. Let's go 2 decimals. 0.03. Okay, 0.042. That equals to 0.042. This value is by CAS. This value is by CAS. Okay, the next one we're talking about is at least half. So I want the probability at x greater or equals to 5, at least half. So the value is actually probability x equals to 5, 6, 7, ... until 10. Right? That's all of those probability. X equals 5, 6, 7, 8, 9, 10. You add all of them up. So it's impossible to do by hand. Okay, it's impossible to do by hand. So you definitely use the calculator. So it's menu 5E, which is the CDF case. 5E. Menu 5E is the CDF case. So number of trials is that, and it's 0.6. The lower bound is not 0. Lower bound is 5. Okay, you start from 5. And your upper bound is 10. You can maximum have 10 and minimum have 5. So it's 5 to 10. And you just press OK. That's easy. And 3 decimals, 0.834. 0.834. Okay, can you see you enter 4 values in this? First 2 are the same compared to PDF, and then you have a lower bound here and you have an upper bound here. So which is 5 and 10. Okay, which is 5 and 10. Okay, I have a really important thing to say before this last exercise. I'm not sure if I have enough time, but I must say it today. For A, if A is asking in this way, but if I asking A in a different way, so find the probability that student A, B, and C in the team, in the sport team. Others not. Okay, I want to find this probability. Okay, I just add another question here. What's the probability I want students exactly A, B, C play in a sport team? Well, A, B, C is particular person. For example, you A, you B, you C. These three play in a sport team. All the rest doesn't play in the sport team. So what is this probability? This probability is not really a binomial case. Well, it is still a binomial distribution, but the way it's asking cannot use a binomial formula because this one will just be 0.6 to the power of 3 times 0.4 to the power of 7. There's no 10-3 in the front. Okay, there's no 10-3 in the front because there's only one way to achieve that. Is U3 play, U7 not play. Okay, it's only one way to achieve that. But for the A, the way it's asking A, there's multiple ways I can have 3 students play in the team. So 1, 2, 3 play, 3, 4, 5 play, 1, 2, 4 play. Like there's multiple ways of achieve 3 students playing in the sport team. But the way asking in, let's say D, there's only one way I can achieve that. So instead of a 10-3, I will have a 1 in the front. You don't really need to write that 1, but there's only one way to have this to be success. So 1, 2, 3, 0.6, 0.6, 0.6, and the other 7, which is 0.4. Okay, so you need to distinguish between this one and the previous one. Okay, they always ask together. They will be always asking together. Okay, so I will finish the last one next lesson.